the new in here. Okay, phase like a mobile phase motion. Okay, so thereby they just stated that the nuclei are assumed assumed to be a stationary, and electrons are in a motions. So since the mathematics of Born-Oppenheimer approximation is complicated, the qualitative physical discussion is given, and by means of neglecting the kinetic energy with respect to nuclear motions. Because here we have mentioned that the nuclear motion is stationary. If it is a stationary phase, there it won't generate any kinetic energy, and thereby, okay, we can neglect the term of k of n term can be neglected. So electronic functions can be obtained by solving the Schrödinger equations. Okay, so the previous equation used to have both the nucleus kinetic energy and the electronic motions kinetic energy. Right now, we have neglected the nuclear motions kinetic energy, and thereby whatever repulsive forces, in addition to that, forces taken with respect to electronic motions. Okay, so the H psi is equal to E psi means with respect to electronic motions, H is E is equal E is psi E. So it is simplified form of equations of Born-Oppenheimer, and thereby E is electronic energy including levels. And by solving this equation, the molecular properties are calculated for a hydrogen-like molecule, and the operator for a hydrogen molecule is proposed. Okay, so it is proposed, and simple harmonic oscillations, and we have just studied the hydrogen-like molecules. We have used the same content here, and in terms of using both the kinetic energy and potential energy with respect to the nuclear motions and the electronic motions. So it is possible to calculate, that is with respect to how the for hydrogen atoms or for atoms, how to get the Oppenheimer approximations. That is based on the number of electrons. That is one electron is present means in the case of hydrogen, it should be given as R of 1. As if it is like helium means it has 2 electron, so you have to take with respect to 1 cases and R2 cases are del 1, del 2 given. Okay, so H cross by 2 Me, and we have to take these 2 cases. So using the that is the Hamiltonian for hydrogen molecule, I think we have studied and seen that it is possible to propose that for helium atom how it will be, and for both the hydrogen atom and helium atoms can be proposed. Okay, and the last hybridization content is present, and I think in the next class we will see. And here we have to study the hybridizations for 3 systems. That is the case of 2 electron systems. Normal systems like ethylene, 1,3-butadiene, cyclic systems like for all the 3 cases, we have to study the hybridizations, and Huckel's approximation should be studied. So today we have just studied about Vodding-based determinants, or how to write the Slater determinants, and Vodding by antisymmetric and symmetric wave functions, and how to apply wave functions for many electron systems like helium, lithium, or beryllium, and etc. And like Born-Oppenheimer approximation by taking both the electrons and the nuclear motions. We just ignore the energy of the nuclear motions. The reason, compared to the electron size, or the nuclear motion is very slow, that is 1,836 times slower. So we just thereby the electron will be moving very fast compared to the nuclear motions. So we ignore that terms, and we just solve the systems Born-Oppenheimer approximation for both single electron like a helium atom, or for single electron like hydrogen atom, and for multi-electrons like helium atoms. That will complete the remaining content, as I told you, the Vodding by Huckel's approximations in the case of 3 systems like ethylene or butadiene or kind of benzene systems. Okay, So just whatever content I forwarded in the last class, just go through it, and if there is any difficulties, just let me know. Okay, so I hope you have studied the variation and perturbation theories and etc. Systems, how the cases for variation theorem and the perturbation theorem. And right now we are focusing in these classes, we are focusing only the many electron systems or multi-electron systems. By taking only, if you take the multi-electron, means by taking both the orbit and spin functions as well as nuclear motions, how to solve the wave functions. So that is the cases we have just started in the case of multi-electron systems. Okay, so with this I'll stop it here, and in the Monday's class we'll complete the remaining content of hybridizations. If there is any doubt or clarifications, you are most welcome. I can say I can respond to your questions. And Monisha. Kavi, எல்லாம் go through பண்ணீங்களா? யாருமே இல்லையாங்க? ஏப்பா மீனா, கவியார், Vasant Kumar, where are you guys? Okay, Kirtana.
Sir. Sir.
சரிப்பா. சொல்லுங்கப்பா.
Sir.
ஓகே, அன்னைக்கு அமிச்சா ஸ்லைட்ஸ் எல்லாம் பாத்தீங்கல்ல?
Yes, sir.
ஏன்னா அதனால தான் I just send it a week before. அதை நீங்க கொஞ்சம் பார்க்கணுங்கிறதுக்காக தான் அனுப்பியிருந்தேன். Go through பண்ணுங்க, and then if there is any doubt, just let me know.
Okay, sir.
அந்த ஸ்லேட்டர் டிட்டர்மினன்ட்ஸ் ரொம்ப பாருங்க. அதே மாதிரி வேவ் ஃபங்க்ஷன் ஜஸ்ட் அதை நீங்க அப்படியே பார்த்தீங்கன்னா தான் கஷ்டமா இருக்கும். ஜஸ்ட் ரைட் இட் ஒன் டைம். ஓகே, ஒரு அசைன்மெண்ட் கூட எழுதலாம் நீங்க, ஒன்றும் தப்பு இல்லை. சரியா? ஸோ பாண்ட் ஓப்பனிங் அப்ராக்சிமேஷன்ஸ் ஆர் இதெல்லாத்தையும் கூட நம்ம எழுதுற மாதிரி ஒரு அசைன்மெண்ட் டைப்ல எழுதுனேன். தட் இட் வில் பி ஈஸி ஃபார் யூ. ஓகே, வாட் எவர் டாபிக்ஸ் டுடே வி ஹவ் டிஸ்கஸ்ட், தட் இஸ் எலக்ட்ரானிக் ஸ்பின் ஆர் வோடிங் பை பாலிஸ் மோஷன்ஸ், அதுக்கப்புறம் இன்னைக்கு என்னென்ன டாபிக் டிஸ்கஸ் பண்ணமோ அது எல்லாத்தையும் ஒரு அசைன்மெண்ட் மாதிரி எழுதி சப்மிட் பண்ணுங்க. அப்போ ஒரு தடவை எழுதுனீங்கன்னா தான் யூ மே அண்டர்ஸ்டுட் வாட் இஸ் த கான்செப்ட் ஹியர். ஓகே, how we can claim it as a why we are called that antisymmetric wave functions சொல்றோம், and what is Pauli's principle என்னது. Okay, how the kind of takes place and all those content you may be followed. சரியா? Just write one time as an assignment, because the next topic in the Hercules approximation வந்து ரொம்ப ஈஸியா இருக்கும். ஒன்றும் இல்லை. சரி, அவன் மேட்ரிக்ஸ் போட்டு அப்படியே சால்வ் பண்ற மாதிரி தான் இருக்கும். சிம்பிள் மேத்தமேட்டிக்ஸ். ஓகே, ஜஸ்ட் லைக் யுவர் குரூப் தியரி கண்டென்ட். அண்ட் டுடேஸ் கிளாஸ் நம்ம இப்போ போட்டது எல்லாமே ஒரு தடவை ஜஸ்ட் ரைட் இட் டவுன் as an assignment so that it will be easy to follow. Okay.
Okay, sir.
Okay, so in Monday's class we will see, and in between if there is any doubt for anyone, just you can call me or you can ask me through WhatsApp. சரியா? Okay, so with this I'll stop it here, and we'll meet on Monday. And in Saturday and Sunday just try to submit the assignment. இப்போ நடத்துறது எல்லாத்தையும் ஒரு தடவை பார்த்து எழுதி பாருங்க, எப்படி வருதுன்னு பார்க்கலாம். சரியா?
Yes, sir.
இன்னைக்கு யாருமா ஆப்சென்ட்?
சார் நிவேதா, அப்புறம் அச்சால் சார்.
நிவேதா and அச்சால். ஓகே ஓகே. Absent.
Yes, sir.
Why they were absent?
Sir, reason சொல்லலைங்க சார்.
Okay. So I can once again congratulate the people, those who selected for that Jayaraman Fellowship, right?